Oh, hi there. This is a tutorial that will show you how to set out questions such as those found in the Cambridge exercise 8F in the Extension 1 textbook. This is question 16. So the main points I want to raise about this is that when you're asked to draw forces, even though the question didn't ask for it, you should always analyze these forces with a separate force diagram. So this over here is called a free body diagram, a term that came from the physics course. But what it requires is that all the forces come out from the dot in the center. So your forces should always be pointing away from the point. Okay, so you can see that there are three forces acting on the object here. We have the two tensions that are angled differently. We've also got the 9.8 going downwards. The second element of the setting out is the naming convention of the directions. So we're going to treat the horizontal as positive going right and vertical as positive going up. So as you can see with this, it allows us to divide the components of each tension force separately. And we need to do each of these tension force separately because they kind of two separate forces and they're going in different directions. So as you can see here, we're working out the horizontal component of tension 1 and the vertical component of tension 1 by drawing a separate triangle. In this triangle, you can see that there is a 60 degrees there, and we've named T1 subscript X. And we also noticed that we use minus because we realized that the horizontal component is pointing to the left, right? So that's something you've got to be conscious of. We do the same thing for T2, both of which components are in the positive direction. When we actually get to answering the question, we have to talk about the net sum of the forces. So what we are really doing here is we're summing all the horizontal components. And by doing that, we're writing them all on the left-hand side. So we're writing them all on the left-hand side like this, and we're equating it to equal 0. And we need to give a reason for why that is so. It's because the particle is not accelerating. According to the Newton's second law, if something is not accelerating, as in not intending to move or change its velocity, the overall force should equal 0, right? Because F equals ma, and here A equals 0. Now, once you've done that, you can see it can rearrange into the desired outcome that you want. So it's actually very important that you write this particular reasoning for why the two things balance. We do the same thing here. We're going to sum all the vertical components. And we achieve a very similar result again. Notice how the gravity is one of the vertical forces, so that contributes to another term on the left-hand side, and that term is negative because the gravity is going downwards. And because of that, the sum of them is equal 0 because the thing is not accelerating. And that arranges into this result that we're required to prove in part B. And the third part is simply substitution. Now, depending on whether the question provides you with the value of T1, T2, or M, you may need to do simultaneous equations with those two equations there. Hopefully that helped.